Hey, what's up, guys? So I'm going to be covering our first grid mission on the modified observed firing chart. All right, real quick, some admin notes for this. The initial setup from the modified observed setup video is exactly the same. The only thing I've altered is changing the numbers to make them a little bit larger just so you can see it better in the video. And then I have a direction of fire, mounting azimuth, and referred deflection already in the proper sequence of classes. That got pulled from the safety diagram class that I will be covering, but I want to push out as many of these modified observer classes as I possibly can before I do so. So if you're confused as to where I get my direction of fire and my refer deflection, that all came from my safety diagram class, which I will cover in the future. All right. Other than that, everything, like I said, is based off of the initial setup video for modified observe. Lastly, I'm going to actually walk through the DA form 2399. All right, so your computer's record, step by step on how it should look as far as receiving the mission from your FO, filling out that information, what you should be worrying about first, and then actions on the plotting board. All right, so I have my computer record here. Usually I fill these out in mechanical pencils, but just so it's easier to see, I will be filling this out in pen. All right, I'm not going to waste my time filling out the date, time, observer ID. Absolutely. If you guys are doing this for real, your organization, just like I've already covered all this information. So if you don't know what this is, refer back to the computer's record video I made, and it all makes sense. So my organization, the date and time in which I received the call for fire, who that call for fire came from, and then later on whichever target number gets assigned to that specific target. All right, so I'm standing by in the FEC, and all of a sudden my observer calls up. We'll just say he's doing a standard grid mission. All right, so check adjust fire. He sends a grid, in this case for me, of 025 628. Gives me an OT direction of 1100 and an altitude of 1430. All right, so grid 025 628, OT direction 1100, and altitude of 1430. He says we have a target description of ammo cache, and he's requesting us to hit this with HE and white phosphorus in the fire for effect. All right, so before I do anything on my plotting board, I'm going to move down into my FTC order and figure out how I want to properly engage this ammo cache. All right, so mortar fire for effect, I'm going to roll with section. Remember, this whole piece here is derived from the FTC chief. All right, I know a lot of places, so like MLOC specifically, right? We will give you the FTC order, and then you'll have to comprise the rest of the information. In real life, real world, you will come up with this information by yourself. All right, my mortar adjust, I'm going to have as my base piece, which is 2 gun or gun 2, depending on who you are and what you like to say. Your method of adjust, I'm going to say 1 round. Remember, that's that 1 round 4.2 gun. I don't have any basis for corrections or sheaf corrections. It's a standard parallel sheaf. And then for my shell and fuse, I'm going to give him exactly what he's asking for here. HE quick, and the adjust, and then the HE and white phos in the effect. All right. My method of fire for effect, we'll go ahead and give him 2 of each. And then it'll be when ready. All right, now that I have all this information filled out, I can go ahead and move over to my plotting board. So we already know, just like I said in the previous video, anytime I need to plot a point utilizing the modified observed firing chart, I need to index 0. So I'm index 0. Now I can go ahead and pull that grid for my target of 025,628. So 0262, and then I can go ahead and add zeros to make my life easier if that still confuses me. So that's 625, that's 500, which I know is 1 black square. And then 628 for my northing, add my zeros, that becomes 800 meters north, 500, 600, 700, and 800. So I can go ahead, make that plot, circle it, label it with a 1, and then I'm going to double check my plot. All right, so 0262, 500, and then 800. So 500, 600, 700, 800. All right, so now I know I'm good. Now, just like for below pivot point, in order to obtain your initial data, you're going to parallel on plot. But first, in order to get our chart deflections, we have to superimpose our refer deflection scale. All right, so like I said, all this information down here in the bottom right of my M16 plotting board, I got from the safety diagram, which I'll cover in a later video. But I have a direction of fire of 0840, a mounting azimuth of 0850, and then a refer to 28. All right, so I'm just gonna go ahead real quick, set this up. All right, so I have my refer deflection scale superimposed on my mounting azimuth of 0850, and then Lars 400 mils to the left and right. All right, so now I have everything I need in order to obtain my chart deflection and chart range. All right, so I can go ahead, parallel line plot my mortar firing position and my target. Remember, like I said in the below pivot point video, anytime you're doing this, you want your mortar firing position closest to you, your target away from you. All right, so if you're pulling data like this, you're wrong, just for the simple fact that the target needs to be away from you. All right. All right, so once I have that parallel line plotted, I can go ahead, get my chart deflection, chart range. And I can fill this information out. Just hit it. Okay. So once I've parallel line plotted, put my range arm up there, got my range 2550, and I have a deflection of 2641. All right. Now, something we haven't covered yet is our vertical interval and our altitude corrections. All right. So in order to determine our vertical interval, we have to compare our altitude of the mortar position and the altitude of the target being engaged. All right, and this is strictly for a grid mission. You're going to compare the altitude of the mortar firing position and the altitude of the target being engaged. And I'll elaborate more on shift and polar missions once we get there and how to obtain your VI, vertical interval. All right, if your altitude of the target is higher than the mortar position, then your vertical interval will be a plus or a positive. If it's lower, it'll be a minus or a negative. All right, and what I mean by that is for vertical interval, let's see, I'll draw a picture on the back here. So I have my mortar firing position, and 3 separate targets, right? So in order for my mortar to hit this, I don't have to apply anything, just for the simple fact that my altitude or my elevation is the same between my mortar firing position and my target. All right, but seeing how these targets are lower and higher, let's say due to terrain, right? So there's, say it's a downslope or a hill going up. In order for us to properly put effects on that target, we need to apply altitude corrections to raise that round and hit our target. So like I was saying, if it's above our mortar firing position, it's going to be a positive or a plus. If it's below, it's going to be a minus. All right. Now, in order to do this, we need to figure out what our altitudes were for our mortar position and our target, because we are doing a grid mission, right? Alright, so I had a target altitude of 1430 and a mortar altitude of 530. Alright, so if I do the math, I compare those two, subtract the smaller from the larger, you're going to get 900. Alright, and because my target's altitude is greater than my mortar firing position altitude, that's going to be a positive number. Alright, so how that's going to look is simply just a plus and then 900. Once again, that 900 is the sum between our target altitude and our mortar position altitude to get us 900. And we know in order to engage that, we have to go up in range, or sorry, up in elevation or altitude. So it's gonna be a positive number. All right, now, I pushed this out in a quiz not too long ago, I think maybe 2 weeks now, on how to obtain your altitude corrections, and I think about 80% of those on this channel who voted got it wrong. All right, so in order to obtain your altitude correction, all you're going to do is take your vertical interval and divide that by 2. All right, and that number becomes your altitude correction. Now, if your vertical interval is a positive, your altitude correction is going to be a positive. If it's a negative, your altitude correction will be a negative. All right, so in our case, I have a positive 900. I divide that by 2 to get my altitude correction of positive 450. All right, now where does this come into play? I need to take that positive 450 and apply it to my initial chart range and any other chart range from here on out to get a command range. All right, so if I do basic math, 450, so 450 plus 2550, that gives me a new command range of 3000, right? I have my azimuth. I read off my referred deflection scale of 1009, and then we can go ahead and compute angle T. All right, remember angle T is the angular difference between our gun target line and our observer target line. So that's where this azimuth is going to come into play in our OT direction, right? So we're gonna compare those two, whatever that sum is, we're going to record it to the nearest 10. So in this case, would be 90. Obviously, it's not in between 500 and 2700, so angle T is not in effect. We don't have to worry about passing that back to the FO. All right. So now all we need to do is go into our tabular firing tables, pull our charge, elevation, time of flight, max horn, and then we can go ahead and fill out our initial fire command. All right, so in these scenarios, if you're a Marine and you're watching this, just bear with me. You probably haven't heard of 300 series ammo. You're probably only familiar with 800 series, but for these scenarios, I'm going to be using the 300 series, which is the old series ammo, as an example, and those range from charge 0 to charge 9. All right, so for this specific scenario, at a command range of 3,000, the lowest charge I can use is charge 6. All right. Once I have that information, my initial chart data is good, I can go ahead and pull the information I need from my FTC order and start filling in my initial fire command. So remember, you're not adding anything from the FTC order over here. You're just plugging and playing and then applying the data that you just pulled from your plotting board. All right, so my mortar to follow is section, shell and fuse, HE quick. Mortar to fire is 2-gun or gun 2. Then we said our method of fire for our adjust is 1 round in the adjust, and then we have 2 HE and 2 white phosphorus in the fire for effect. And because I'm using 300 series ammo, HE and white phosphorus are ballistically compatible. All right, so the data remains the same. If you're looking in the TFT for 300 series ammo, white phosphorus falls under HE because the ballistics match. All right, so I'm going to pull my deflection over to get a command deflection of 2641. I said it was charge 6. My elevation from the TFT is 1028. I had a max ward of 1352 meters and a time of flight of 33.3. Alright, once I verify I like what I see, and go ahead, pass that to the gun line, fire that round, circle it. Now, a good habit in the FTC is anytime you fire around and you're waiting for correction is to index your OT direction and stand by. All right, so I had an OT direction of 1100, so I can go ahead, rotate my azimuth disc and index that OT direction of 1100. And now I'm simply just standing by for any corrections from my FO. All right. Now with this, moving back to my computer record before I start getting these corrections, I want to pull my altitude correction and bring it down to my chart and safety data range and just pencil it in there. That way, once I pull my chart data, I get my chart range, I'm going to apply that altitude correction to get my command range here. All right, and I'll show you what that looks like here in a second. All right, so I'm standing by. Observer comes back and he says, add 50, fire for effect. All right, so add 50, fire for effect. Once I have that written down, I can go ahead and apply this to my plotting board. So there's 2 different ways you could do this. Either your range arm or your protractor. All right, I'm just going to use my range arm to make this quick. Ensure that it's straight up and down. And he gave me an add 50. So once I have that, I can go ahead, circle it, put a 2, and then all I need to do is parallel line plot that new correction, that second plot with my mortar position, and then pull data, chart data, just like before. All right, so I have my chart deflection. Okay, go ahead, get my chart range. I have 2600. So getting a chart deflection now of 2640. And then I said I had a chart range of 2600. I made my fire for effect, so I know my mortar fire is going to change from 2-gun to section. So I'm going to write section. They're firing 2HE and 2 white phosphorus. I can bring that deflection over because I don't have a deflection correction to apply. So now I have a command deflection of 2640. And then I need to obtain my command range. So if you didn't watch the computer's record video I made, you'll know the big change between the old computer record, the TAC Romeo, and this one was this box here. All right, so this used to be a range and charge box. So I'm simply going to make it look like it used to. And then I can go ahead, I'm going to apply my altitude correction of positive 450 to my chart range. That's going to give me my command range of 3050. Now I'm going to look at my TFT, see if I'm still in charge 6. If I am, which I am, I can go ahead and leave that blank because you only need to annotate something if it changes. All right, so I'm not gonna waste my time with that. I can go ahead and fill in the elevation that I got out of my TFT for a range, command range of 3050. I'm going to ensure I pass this information to the entire section. They're going to fire, and then now I can update my total rounds expended. And I have 9 HE and 8 white phosphorus sent down range, right? Just because we like to practice good habits. Although he did say fire for effect, he could give us a repeat. So we're going to re-index our OT direction of 1100 and stand by. All right. Now, as we're standing by, he does in fact come back and says end of mission, and he gives us a BDA of cash burning. All right, and then once I have that filled out on my computer's record, I can move back into my plotting board, and all I'm going to do is erase that first plot, keep my second plot, erase the circle, and then I'm going to make my hollow cross and label it with the appropriate target number. All right. Just for the simplicity of this video, I'm not gonna go ahead and do that, just because it takes a little bit longer with map marker or the map pen. All right, so just understand, once I've completed this mission, keep the last plot, erase everything else, turn that circle with a 2 into a hollow cross, and then you can go ahead and now label it with the appropriate target number and altitude. All right. So just to recap, I started with the basic setup for Modify Observe from my previous video. I had a grid index of 0163. I plotted my mortar point and my observer just in case I need him. And then I superimposed my refer deflection scale that I got from my safety diagram class. Once again, I will push that out to you all in the future. So I superimposed my refer deflection scale. Now I'm just standing by, waiting to be told a target grid. All right, so he gives me a grid mission. I applied that grid to my Modify Observed firing chart, indexed at 0, and then parallel line plotting, pulling your information and filling it out on your computer's record. Now remember, like I said, now we're dealing with vertical interval and altitude corrections. You're comparing the altitude between, for a grid mission, you're comparing the altitude of your mortar position and your target that you are engaging. The difference of those two altitudes is your vertical interval. All right, so if my target's altitude in this case is greater than the altitude at which I am at, I know I have to increase altitude or elevation. That's going to be a positive VI. All right. If I'm shooting down and on a downslope, it's going to be a minus or a negative VI because I'm losing altitude. All right, once I have my VI, I can go ahead and divide that by 2, and that's how we obtain our altitude correction. All right, just remember, if our VI is a positive, our altitude correction is a positive, and vice versa for negatives. All right. Once again, I am using 300 series ammo, so don't let that charge 6 confuse you. For those who have never seen 300 series ammunition, the HE and white phos for 300 series ammo are ballistically compatible, so the data remains the same for those 2 rounds. And then just getting a good habit of bringing the altitude correction down to your chart and safety data range, that way you can apply it to any chart ranges to obtain your new command range on your computer records. All right. And then always update your total rounds expended at the end of every mission, and then close it out with your BDA. All right. Like always, if you haven't done so already, go ahead and subscribe to the Checker Hold YouTube channel. Drop a comment if you have a question or if there's something different that you would like to see. And also feel free to message me on Checker Hold Instagram with anything, any comments pertaining to this specific class.